The idea of the multiverse is one of the most wild, mind-blowing, and fascinating ideas in modern physics.
I don't know about you, Aaron, but to me, the concept of an infinite number of universes, each with different laws and constants of nature, sounds more like science fiction than science.
I hear you, Ellie, but remember, many of the world's greatest physicists believe it's true.
Right. They realize that they need infinitely many parallel universes to get around the clear indication that one intelligent cause fine-tuned our one universe.
Welcome to Season 2 of Physics to God, Understanding and Rejecting the Multiverse.
Welcome. This is Physics to God, a guided journey through modern physics to discover God. My name is Eli Fader, and I'm an Orthodox rabbi and a mathematician.
And my name is Aaron Zimmer. I'm also an Orthodox rabbi with a deep interest in physics and philosophy. On this podcast, we'll discuss some of the most fascinating developments in physics and make a convincing argument that they point directly to the existence of God. For those of you who don't know, the multiverse is a popular theory about an infinite number of parallel universes that exist alongside our own. In this series, we'll explain all the essential features of a successful multiverse and analyze all its scientific supports. After that, we'll show step by step what's wrong with the multiverse, why it fails to qualify as a scientific theory, and even why it fails as a good philosophical theory.
We know that right off the bat, some of you will dismiss the multiverse as a wild and crazy theory. We get that. It does sound kind of bizarre.
But some of the most brilliant scientists in the world take it seriously and believe that it's the best alternative that science has to offer to the intelligent cause implied by fine-tuning. So we felt compelled to analyze it in depth so you could see firsthand why it fails to be a viable scientific theory.
In the first 5 episodes of our first series about an intelligent cause, we discussed at length the mystery of the constants of nature and the problem of fine-tuning. If you didn't listen to that, don't worry. We'll review the basic ideas and provide all the background necessary to understand the multiverse.
Though we've made this a standalone series, if you want to hear the argument for an intelligent cause in more depth, we recommend starting with our first series about an intelligent cause.
And just like last season, we're going to explain everything to you in clear and simple language, so you'll be able to understand all the essential concepts, even if you have a limited background in science. I spoke to Aaron in the off-season, and he told me that this time he'll make an extra effort to explain the physics in an even more straightforward manner, so that just like last time, everyone can comprehend.
I said that? I don't remember saying that.
Okay, I told Aaron that he should do that. Rest assured, any physics that Aaron makes too complicated, I'll simplify through helpful analogies. By the end of this series, everyone will be able to understand the essential components of the multiverse, appreciate the evidence scientists use to support it, and see exactly where the theory inevitably goes wrong.
While we'll explain everything you need to know about the multiverse in this series, we highly encourage you to search the internet for articles and videos of the world's top scientists explaining the multiverse and fine-tuning.
This independent research has 2 benefits. First, you'll see that we're accurately representing their views and that we haven't left out any significant points. And second, nothing we say will be as convincing as seeing scientists explain the multiverse themselves.
Ellie means that the most convincing way to know that fine-tuning, design, and order in physics are clear indications of God's existence is to hear top scientists say that these problems led them to believe in an infinite number of unobservable universes.
Okay, let's start by summarizing the basic argument from last season, so everyone understands the backdrop for the multiverse.
Our journey began with scientists' discovery of fixed numbers built into the fundamental particles and laws of nature. These 25 or so unchanging numbers, known as the constants of nature, determine the quantities for the particles and laws. 2 examples are the mass of an electron, a number that describes how heavy it is, and the fine structure constant, a number that describes the strength of the electromagnetic repulsion between 2 electrons.
As the 20th century progressed, modern physics was quite successful in at least partially realizing physicists' dream of finding a theory of nature that explains everything in the universe. However, the specific values of the constants presented a unique challenge. The mystery was, how can a theory of everything, a master law of nature, explain numbers like 137.035999139?
The mystery was implicitly based on the belief that these numbers were arbitrary, with no reason for their specific values. This was a perfectly justifiable assumption. From the perspective of theoretical physics, the constants could have taken on any values whatsoever. So why did the constants have these values and not some other values? Richard Feynman called the problem of explaining these values one of the greatest damn mysteries of physics.
The discovery of fine-tuning provided the all-important clue. It illustrated that the values of the constants are not as arbitrary as they had seemed. Beginning in the 1970s, scientists realized that while the values of the constants don't matter in terms of fundamental physics, the fields of astronomy, chemistry, and biology, among others, demand that these values are precisely tuned. That is, if these numbers were slightly different, the universe would be devoid of atoms, molecules, planets, stars, galaxies, and life. As such, fine-tuning can be seen as the reason why our universe contains order, structure, and complexity.
In scientists' quest to explain the cause of the values for the constants, it became evident that the precision of the fine-tuning was too great to be chalked up to a lucky coincidence. The odds of getting all the values within the correct ranges is staggeringly low.
Furthermore, the discovery of fine-tuning eliminated two other possibilities for explaining the values of the constants. The first being that the values of the constants are brute, uncaused facts. And the second is that there is some master law of nature that determines the exact values of the constants.
This is because neither of these two possibilities could explain fine-tuning without resorting to a massive coincidence, insofar as neither theory explains the relationship between the values of the constants and the resultant universe. It became clear to physicists that the discovery of fine-tuning is too significant a clue to ignore, and that any theory that would explain the values of the constants would have to also explain why they're so fine-tuned.
While it couldn't be denied that fine-tuning is a vital clue for explaining the constants, its discovery presented a real problem to the ordinary scientific paradigm. You see, modern science generally proceeds by explaining how the laws of nature cause complex phenomena in the universe. But fine-tuning seemed to indicate the exact opposite, that somehow the future result of having a complex universe with atoms and molecules caused the specific quantities for each constant. From the ordinary scientific perspective, this seemed backward.
In the previous series, we presented our solution to the problem of fine-tuning. We argued that fine-tuning indicates that the cause of the constants' fine-tuned values is the purpose of bringing about an ordered, structured, and complex universe. On this basis, we argued that the cause that precisely fine-tune these values for the purpose of bringing about our complex universe must be intelligent.
This follows from the definition of intelligence as the ability to select or choose one option from the set of many possible choices for the purpose of achieving a particular objective. Because fine-tuning is a hallmark of intelligence, it indicates that our universe has an intelligent fine-tuner. Therefore, the discovery of fine-tuning forces those who seek to deny an intelligent cause of our universe to provide a viable alternative explanation.
While almost all scientists accept the fact of fine-tuning, most scientists don't accept the implication of an intelligent fine-tuner. They immediately identify the proposed fine-tuner with a childish idea of God. They have many difficulties and problems with the idea of God, and in our next series, we'll fully address their questions and reservations about the intelligent fine-tuner.
So far, we've reviewed the basic structure of the argument from fine-tuning of the constants. In episode 7 of the previous series, we presented a second argument, that the special design of the laws of nature, general relativity and quantum mechanics, indicates an intelligent cause. We illustrated how an intelligent cause solves the problem of why our universe is governed by our laws of physics and not any other potential laws. The solution is that our laws are unique in their ability to naturally bring about a universe with order, structure, and complexity.
Finally, in episode 8 and 9, we argued that the highly improbable initial conditions of the universe provide a third argument for an intelligent cause of the order in our universe. Had our universe started in a random state, the overwhelming likelihood is that it would be filled entirely with black holes. It's only because of the incredible order at the Big Bang that amazing structures such as galaxies, stars, planets, and life exist anywhere at all. The term universe historically referred to all existing matter in space. However, multiverse theory suggests that what we call the universe is merely one small part of a large set of universes called the multiverse.
It also suggests that the known laws, constants, and initial conditions at the Big Bang only apply to our universe. Different universes in the multiverse are proposed to each have their own laws, constants, and initial conditions.
The first usage of multiverse in modern history was in 1895 by Ludwig Boltzmann, the discoverer of the statistical law of entropy. When Boltzmann first suggested a multiverse as a possible solution for the unexpectedly low entropy of the universe, it was considered a speculative and non-scientific theory that few took seriously. In the 1970s, multiverse theory was revived by Brandon Carter and Martin Rees as a possible solution for the fine-tuning of the constants. With the progress of time, the theory is rapidly becoming part of mainstream cosmology. Many scientists consider it to be the best explanation for the fine-tuning of the constants of nature, the design of the qualitative laws of nature, and the ordering of the initial conditions of the universe.
The question of whether a multiverse is real has great relevance to the interpretation of fine-tuning. If only one universe exists, it's unreasonable to explain the special features of our universe by chance alone. How could the laws, constants, and initial conditions be just right for the emergence of our complex universe when the odds of this occurring by pure chance are so staggeringly small? However, assuming the existence of a multiverse, physicists can reasonably invoke chance to explain the special features of our universe.
In making this case, physicists concede that it's highly unlikely that the laws, constants, and initial conditions have the right values in any one particular universe in the multiverse. However, if there are enough universes, each with its own random set of laws, constants, and initial conditions, then there will very likely be the perfect combination in some universe in the multiverse. Of course, if there are an infinite number of universes in the multiverse, then every possible universe, including some like our own, must exist somewhere in the multiverse.
This line of reasoning is used to explain the fine-tuning of the constants and the design of the qualitative laws of nature as follows. If there are an infinite number of alternate universes, and each universe has a different set of laws with different values for the constants, then there is certainly at least one universe for every possible set of laws and values. Because the laws and values necessary to produce a complex universe are so specific, almost all the alternate universes would be chaotic nonsense. However, at least one of them would by chance alone have the special laws and values that we observe in our universe.
One may naively ask the following question on this solution. While it's true that somewhere in the vast multiverse, we would find a universe that happens to have the beautifully designed qualitative laws of nature and precisely fine-tuned constants, what are the odds that it happens to occur in our one universe?
This question is easily sidestepped by noticing the observer bias implicit in our observation of our universe. The only type of universe that an intelligent observer is even capable of observing is one with the right laws, constants, and initial conditions. Though there are many more disorderly universes than ours, since intelligent observers couldn't exist in any of them, there's no question why we aren't in one of those more common universes.
Physicist Leonard Susskind in The Cosmic Landscape explains this point. A megaverse of such diversity is unlikely to support intelligent life anywhere but in a tiny fraction of its expanse. According to this view, many questions such as, why is a certain constant of nature one number instead of another, will have answers that are entirely different from what physicists had hoped. No unique value will be picked out by mathematical consistency, since the landscape permits an enormous variety of possible values. Instead, the answer will be, somewhere in the megaverse, the constant equals this number, somewhere else it is that number. We live in one tiny pocket where the value of the constant is consistent with our kind of life. That's it. That's all. There is no other answer to this question. Many coincidences occur in the laws and constants of nature that have no explanation other than, if it were otherwise, intelligent life could not exist.
Just a historical tidbit. If you're wondering why Susskind called it a megaverse, that quote is from 2006, before the multiverse had become really popular, and everyone was using their own terminology. Now that the idea has become so widespread, pretty much everyone calls it the multiverse.
I kind of like megaverse.
Talk to Marvel, Aaron. Maybe their next movie can use megaverse, and they can revive the term. In the meantime, let's move on.
Okay. Physicists use the same basic line of reasoning to explain the low entropy initial conditions of our universe. If there are truly an infinite number of universes in the multiverse, each with a random arrangement of its initial conditions, All sorts of universes, ranging from those with total chaos to maximum order, would exist. Almost all universes would have less order than our universe, which has at least 100 billion ordered galaxies. Although the vast majority of universes would contain only black holes with no atoms, planets, stars, or galaxies, at least one universe would happen to have the incredible order of our universe.
Aaron, I'd like to make a suggestion that won't be 100% correct, but will help simplify our discussion of the multiverse.
Okay, I'm listening, Ellie.
I've noticed that Multiverse provides the same basic explanation for three special features of our universe: the design of the qualitative laws of nature, the fine-tuning of the constants of nature, and the ordering of the initial conditions of our universe. Therefore, we'll often talk about all three of these things together. To avoid the cumbersome repetition of the phrase, the design of the qualitative laws of nature, the fine-tuning of the constants of nature, and the ordering of the initial conditions of our universe, I think we should take the liberty of referring to Multiverse's explanation of all three of these features by merely referring to its explanation of fine-tuning.
I'm not sure. Sometimes by dropping the complexity, you obscure subtle and important differences. Remember, Ellie, we don't want to oversimplify things.
I hear your point. How about when we want to single out one of these features, either the design of the laws, the fine-tuning of the constants, or the ordering of the initial conditions, we'll make it explicit. How does that sound?
All right, Ellie, that's a good idea. It's important to understand that not all versions of the multiverse can explain fine-tuning. The only multiverse capable of explaining fine-tuning without an intelligent cause is an infinite, varied multiverse, in which our universe is typical.
Whoa. Slow down, Aaron. What Aaron means is that there are three essential components that multiverse theory must posit to successfully account for fine-tuning. Many people gloss over this key step, but it's crucial to break down multiverse theory into its core components to see how it works, as well as how it ultimately fails to work. The three components, which we'll also call the three premises, are: 1, there are infinitely many universes. 2, these universes are varied. That is, they each have different laws, constants, and initial conditions. And 3, our universe is a typical universe in the multiverse. Let's analyze these three premises one at a time. Aaron, you can start with the infinite multiverse premise.
To make chance a reasonable explanation of fine-tuning, the multiverse must contain an enormous number of universes. Specifically, the number of universes must roughly match the odds of attaining all the laws, constants, and initial conditions by chance alone.
In other words, if the probability of randomly getting the right constants is 1 in a million, then around the million universes would make it likely to get fine-tuned constants in our one universe by chance alone. If the probability is instead 1 in a billion, then a billion universes would suffice. The truth is that it's much, much less likely than 1 in a billion. Though there's no clear method of making an exact calculation, physicist Lee Smolin has estimated the odds of getting all the constants just right as 1 in 10 to the 229th power. This would demand around 10 to the 229 universes in the multiverse to make our constants likely by chance alone.
Turning from the constants to the ordered initial conditions of our universe, recall from episode 9 of our previous series, physicist Roger Penrose's calculation that the probability of getting our initial conditions by chance alone is 1 in 10 to the 10 to the 123rd, a double exponent. Based upon these odds, we would need around 10 to the 10 to the 123rd universes in the multiverse to explain the initial conditions by pure chance.
To appreciate why they need so many universes, consider the analogy of a pick 25 lottery. If on your first try you pick 25 numbers, each from 0 to a billion, and get them all exactly correct, it would be clear that chance can't possibly explain such good luck. The odds are just too small. However, if you didn't only buy one ticket, but bought trillions and trillions of tickets, then you'd realize that chance is a perfectly reasonable explanation for your one winning ticket. After all, you bought so many tickets that would virtually ensure that at least one of the tickets would win.
Because scientists realize the immense challenge of developing a scientific theory that naturally generates an enormous number of universes and no more, on a practical level, all multiverse theories posit an infinite number of universes. The idea of infinity and the problems associated with it is of crucial importance for multiverse theory and is something that we'll be speaking about a lot over the course of the coming episodes.
The bottom line is that without an actual infinite number of universes, or at least a number so big that it practically functions like infinity, the odds make it entirely unreasonable to randomly get our special values by chance alone. This was the infinite multiverse premise. Aaron, please tell us about the varied multiverse premise, the second component that's needed for multiverse theory to explain fine-tuning without an intelligent cause.
The varied multiverse premise claims that even though the values of the constants are fixed and unchanging in our universe, in the multiverse, the values of the constants are not truly constants, but are more akin to variables. In other words, there's some mechanism that assigns different values to the constants in each universe in the multiverse. Every multiverse theory must contain some random number generating process for assigning these values. Without such a mechanism, the constants wouldn't differ from universe to universe, and the problem of fine-tuning wouldn't be addressed.
To clarify this point, it's important to distinguish between a theory that posits many fine-tuned universes and a varied multiverse. Many fine-tuned universes refers to a group of universes that all have the same constants as our universe. The existence of such a collection of universes has no bearing whatsoever on the issue of fine-tuning. If all the universes have the same fine-tuned constants, then the question still exists as to what caused the constants in all the universes to have these special values. Nothing is gained by merely positing that there are many fine-tuned universes as opposed to one fine-tuned universe.
In contrast, a varied multiverse refers to a group of universes in which the values of the constants randomly vary from one universe to another. This variation is needed for the multiverse to explain fine-tuning. In other words, the multiverse must posit an infinite number of different universes to get an infinite number of attempts at getting the constants just right.
To understand the importance of the varied multiverse premise, let's go back to the lottery analogy. Imagine you buy trillions of tickets in which you choose the exact same 25 numbers for every single ticket. If you happen to win with all the tickets, then because the odds of winning are so mind-bogglingly small, chance would be a very poor explanation for your success. The fact that you bought trillions of identical tickets doesn't help the situation.
Since you chose the same numbers on all trillion tickets, you're no more likely to win when buying a trillion tickets than buying just one ticket.
Here's the main point. Just like the combination of trillions of tickets and pure chance can only explain you winning the lottery if you choose different numbers for each ticket, so too the combination of infinitely many universes and pure chance can only explain our fine-tuned universe if the constants are different from universe to universe.
Despite this crucial point, many scientific discussions fail to distinguish between these two fundamentally different ideas, many fine-tuned universes and a varied multiverse, and instead call them both multiverse. In the next two episodes, we'll show how many of the arguments that scientists put forth in support of a multiverse are in truth only supports for many fine-tuned universes, but do nothing to support the varied multiverse premise, which is just as necessary to explain fine-tuning.
For the sake of simplicity, we will often just say multiverse and leave out varied. But keep in mind that we'll always use the term multiverse to refer to a varied multiverse and not to many fine-tuned universes.
While it may seem that these first two premises are all that's needed to explain fine-tuning with a multiverse, that is a naive assessment. Later in this series, we'll thoroughly illustrate the fundamental flaws of a theory that's only comprised of these two premises. Because of these clear problems, multiverse scientists don't maintain such a theory. It's only found in popular presentations that naively oversimplify the multiverse.
Aaron, can you tell us the third component that's necessary to create a complete multiverse theory?
The typical universe premise is the claim that our universe is a typical universe from the set of all the types of universes that have intelligent observers.
Wow, that was really concise, Aaron. Because this point is really subtle, we'll need to explain it a little more than that. Also, while we'll have a lot more to say about this premise in future episodes, for now, let's just try to introduce the basic meaning of this premise and give a sense of why it's needed.
Okay, Ali, that's a good point.
And listeners, try to follow the basic idea. Because of the complications of the typical universe premise, I urged Aaron to leave it until later. but he thought that we should try to at least introduce it here. And I actually agree with him on this point. Given that there are 3 premises needed for Multiverse to explain fine-tuning, we should mention them all at the outset, even though we can't fully develop the 3rd premise in this episode. But don't worry if you don't really follow the point. We'll develop it a lot more later.
Okay, Ellie. Let's start this way. Out of the vast number of universes in the multiverse, we can assume that only a small subset of them contain intelligent observers. Of course, it's unreasonable for an intelligent observer to ask why they happen to be in this small subset. After all, there simply are no intelligent observers in the other universes to even ask this question. So right off the bat, we can understand why our universe doesn't look like any of the universes without intelligent life, because it's impossible for us to even exist there.
I understand what you mean, but you're not saying anything new. We've already explained that an intelligent observer can only exist in one of the universes capable of supporting intelligent observers.
I'm not done yet, Ellie. So it's clear why it's unreasonable to ask why you're in a universe with intelligent observers. However, not all universes with intelligent observers are the same, and it is reasonable for an intelligent observer to expect to be in a likely or typical universe within this subset of universes with intelligent observers.
Let me explain what Aaron means when he says we expect to be in a certain type of universe. The relevance of Multiverse to our discussion is that it attempts to explain our special fine-tuned universe as a result of an infinite varied multiverse and pure chance. While this is enough to invoke the observer bias and explain why our universe has intelligent observers, that's not enough to invoke pure chance to explain all the other complex existences in our universe that don't depend on intelligent observers.
Right. It's only reasonable to use chance to explain our observations if all our observations are in line with the predicted odds.
Let me explain this in a little more detail. Consider all the various types of universes that have intelligent observers. While they're all different from one another, they share in common the fact that they all contain intelligent observers. Let's consider some examples of universes in this subset. One universe contains just one intelligent observer and nothing else. Another contains one planet with intelligent observers. Another contains one entire galaxy that has only one planet with intelligent observers. And yet another universe like ours contains over 100 billion galaxies with over 100 billion stars each, in addition to intelligent observers. The list of different types of possible universes with intelligent observers goes on and on. So why do we find ourselves in this universe with intelligent observers and not some of the other universes with intelligent observers?
The answer that multiverse scientists give and must defend is that when we consider all the universes in the vast multiverse that contain intelligent observers, our universe is not special and unique, but is rather typical and mediocre. In the words of Brian Greene in The Hidden Reality, life may be rare in the multiverse. Intelligent life may be rarer still. But among all intelligent beings, the anthropic assumption goes, we are so thoroughly typical that our observation should be the average of what intelligent beings inhabiting the multiverse would see. Alexander Vilenkin has called this the principle of mediocrity.
We know this might sound confusing at first, and it really does need more explanation. I have a fancy analogy using marbles that explains this premise and why it's absolutely necessary, but I'll hold off on it until we're ready to take it up in more depth. For now, we just wanted to convey the basic idea of what a typical universe means and provide some explanation for why it's needed. But again, if you don't get it right now, don't worry. You will when all is said and done.
Wow, Ellie, did you just pass on an opportunity for another analogy? It kind of sounds like your analogy is complicated too. My kind of thing. Now I really want to hear this fancy marble analogy.
All in due time, Aaron. We can now see how a complete multiverse theory explains the fine-tuning of the constants. It begins with 3 premises. 1. The infinite multiverse premise claims there exists a multiverse composed of infinitely many universes. 2. The varied multiverse premise claims that in the multiverse, the constants vary from universe to universe. And 3. The typical universe premise claims that of all the universes in the multiverse that contain intelligent observers, our universe is typical.
Putting the 3 premises together, we can say the only multiverse capable of explaining fine-tuning without an intelligent cause is an infinite varied multiverse in which our universe is typical.
Let's summarize how these 3 premises come together to explain fine-tuning. The question of fine-tuning was, Why are our constants of nature so fine-tuned to produce the order and complexity found in our universe? Armed with these three premises, complete multiverse theory gives the following answer. The infinite multiverse premise tells us that our universe is but one of many universes in the infinite multiverse. The varied multiverse premise tells us that all these different universes have different values of the constants.
When considering all these different universes, we can clearly see that even though intelligent observers can only exist in a small fraction of them, fine-tuning is a necessary precondition for a universe that contains intelligent life. Being that we are intelligent observers, we could obviously only exist in a universe where the constants are just right. This is because there simply are no intelligent observers in the universes with the wrong constants. Thus, this theory naturally explains our observations of the apparent fine-tuning of the constants of nature, and it is no longer surprising that we find ourselves in our apparently fine-tuned universe. This line of reasoning is called the anthropic principle.
However, this only explains why our universe is fine-tuned for intelligent observers. Besides merely containing intelligent observers, our universe contains other things, like 100 billion galaxies with 100 billion stars each. Since our universe contains a lot more than just intelligent observers, we can ask why we are in this universe and not, for example, in some other universe containing intelligent observers, but only one galaxy.
Complete multiverse theory answers with the typical universe premise that our universe is a typical universe containing intelligent observers. It should therefore come as no surprise that we happen to find ourselves in this type of universe with intelligent observers as opposed to any other. Since our universe is typical in this subset, it simply follows based on probability.
Based on this line of reasoning, a complete multiverse theory claims that fine-tuning is only an illusion. Our observation of what we consider to be fine-tuned constants simply results from an observer bias. However, if we could actually see the constants of all the other universes in the multiverse, we would conclude that on the large scale of the entire multiverse, there is no fine-tuning at all, just a bunch of universes with random constants. As such, there's no need to posit an intelligent fine-tuner to explain our apparently fine-tuned universe.
We've oversimplified things by introducing the three premises of multiverse theory in the context of the fine-tuned constants alone, without connecting the three premises to the design laws and the ordered initial conditions. Now, let's broaden our discussion and bring back a bit of accuracy and complication with 2 points.
Sounds good, Aaron. First, in the prior series, we presented three distinct lines of evidence that point to an intelligent cause of our universe: the fine-tuning of the constants, the design of the qualitative laws of nature, and the ordering of the initial conditions of our universe. While multiverse is relevant to them all, not every version of the multiverse explains all three facets of our universe without an intelligent cause. Some versions only explain one or two of them. We'll be sure to specify when a version of multiverse only solves one or two facets, but not all three.
Second point, there are currently many different versions of the multiverse. While some versions have parallel universes coexisting side by side in an infinite array of separate universes, other versions propose a series of universes existing one after the other in time, and there are some even more exotic versions. Additionally, different multiverse theories propose different mechanisms for assigning the different laws, values of the constants, and initial conditions to each universe. Brian Greene, in his book, The Hidden Reality, presents at least 9 different categories of multiverse.
Regarding some scientific issues, it makes a difference which type of multiverse one accepts or studies. However, to explain the apparent fine-tuning, design, and order of our universe, it doesn't matter which multiverse theory one selects. They all demand the same three premises. Thus, in the following episodes, when we raise difficulties with multiverse theory and its explanation of fine-tuning, design, and order, those difficulties will generally apply equally to all the different versions of the multiverse.
And when a part of our argument only applies to some particular versions of the multiverse, we'll be sure to mention it.
Let's move on to our final point. A complete multiverse with all three premises explains fine-tuning, design, and order without the need for an intelligent fine-tuner. The question is it legitimate for multiverse scientists to simply posit these premises, or must they be justified? To answer this question, let's revisit last season's discussion regarding the burden of proof.
In general, anyone who wants to assert something must supply evidence that indicates their assertion is true. Once they supply evidence, the burden of proof shifts to their opponent to find evidence that indicates an alternate explanation.
The question of whether or not the cause of our universe is intelligent is intrinsically an open question. The burden of proof is on anyone who wants to show that either the universe does or does not have an intelligent cause.
In our first series, we didn't come in with an assumption one way or the other. Rather, we presented a compelling argument based on the scientific discovery of our universe's fine-tuning, design, and order. Since fine-tuning, design, and order are the fingerprints of intelligence, not randomness, these scientific discoveries provide evidence that indicates that our universe has an intelligent cause.
Because this evidence directly indicates an intelligent cause, not a multiverse, it shifts the burden of proof to those who deny an intelligent cause. For multiverse scientists to undermine these arguments, it doesn't suffice for them to merely speculate that there are an infinite number of unobservable universes with different constants, laws, and initial conditions, and that our universe is typical. Rather, they have the burden of proof to support these claims and provide evidence for their three premises. If this point about the burden of proof bothers you, you can hear a fuller treatment of it, with analogies, in episode 10 of season 1.
Besides the ordinary demand for justification that any theory has, we want to emphasize that multiverse theory's three premises are extremely bold and highly unintuitive. At first glance, an infinite varied multiverse is an unintuitive conclusion to draw from our observation of one fine-tuned, designed, and ordered universe.
First, the premise that there are infinitely many other universes besides our one observed universe is an extraordinary claim that demands evidence. Second, while it's reasonable to assume that each universe would have different initial conditions, the premise that the laws and constants vary from universe to universe goes against all our observations of the universality of the laws and constants of nature.
And third, justifying the premise that our universe is typical is no simple task. A bit of reflection indicates that the opposite appears to be the case. It's a highly dubious claim that the typical universe with an intelligent observer also contains an additional 100 billion galaxies with 100 billion stars each. We'll discuss this point much more later on.
The bottom line is that multiverse scientists need to provide concrete evidence for their astonishing claims. Observing one universe doesn't indicate infinitely many universes, and observing universal fixed laws and constants seems to contradict the entire notion of varied laws and constants. And our amazingly complex universe seems far from typical.
In the coming episodes, we'll examine and analyze multiverse scientists' support for their three premises.
We'll thereby assess whether the multiverse is a valid scientific theory that meets the burden of proof and accordingly explains the fine-tuning of the constants, the design of the laws of nature, and the ordering of the initial conditions without the need for an intelligent cause.
I'm excited, Ellie. We're going to have a lot of fun exploring the wild world of the multiverse.
Stay tuned for next time when we begin examining how multiverse scientists justify their belief that there actually exists an infinite number of parallel universes that nobody can ever observe.